Hi, this is your host Habib Zakaria, and I'm a network solutions architect with Cataclipse Computing Solution. My website is www.cataclipse.com. We also have cloud services. It's under shop.cataclipse.com, and I hope that whenever you have a chance, you can go and visit my website and to know more about my cloud solutions. Um, but enough of me. Let's start our lab, which is about provisioning static NAT. As I mentioned in my previous lesson, I was involved with a manufacturing facility, and we had a lot of vendors coming in with their hardware terminals, and those could have been controllers for the machineries or small terminals that they will place them in our plant, and the vendors would be somewhere else traveling around the world, and they would like to know the status of their readings on the equipment. And this was exactly the solution I provided in front of you. And I hope my experience comes valuable to you as an individual who's now trying to learn how to do static NAT. So let's start with no hesitations. And what we will do first is we will configure the back end, which is basically R1 and R2. So as I said, R1 is basically your part of your internal network. It's the CE router. R2 is part of the external network. That could be an ISP or some other company that came in to connect, that came in to provide an internet access to your organization. Mostly it's going to be an ISP, right? The other part is the switches. There's the switches on each side of the network, as always, as you know, and my terminal is going to be this one, which is the focus of our scenario here, where this one has an internal IP address, whereas the user is a remote user connected to an ISP, and that person will reach this terminal using a public IP instead of an internal IP. Between the two routers, of course, there's an public IP here that was given to the internal organization. This public IP has 6 host IP addresses available. That means I can use from 100.20.190.1 to all the way 6. So basically .1 and .2 will be given to these two interfaces here under R1 and under R2. The third one will be .3. We will give it to the terminal. We will give it as a NAT IP address for this terminal. So basically the task 1 is assign IP addressing. Task 2 is use any routing protocol to make sure that the networks converge. And finally, it's going to be a test that we will have to do from a remote user workstation to a terminal, connectivity to the terminal station. Okay, so let me bring up the router 1 and start the configuration, and we will continue from there. Okay, so we have R1 that came up, and we will start configuring the interfaces as per the task 1 indicates. So let's just make sure that we have all the interfaces are in the down state, as you can see. So the first one is interface F0/1. or F0/0. Let's configure that. And as we said, it's 100.20.190. We will assign this interface .1, 255.255.255.248. /29 means 248 subnet mask. No shut. Now let me go to interface F0/1. IP address is 192.168.1.1, 255.255.255.0. That's /24 range. No shut. Now, the other thing of this simulation is basically also for you to get familiarity with the routing. So what we will do is we will apply a dynamic routing protocol RIP. So router RIP version 2, and so there's two networks here. Network 1 is 192.168.1.0, and the other network is the 100.20.190.0. No auto summary is a good practice to do that. If you want to know more about how I did the dynamic routings, I have other courses on Udemy that might be useful to take. So we are done with the router 1. Let me start router 2 and bring it up. Okay, so we have R2 here, and we will start with the configuration of the interfaces. This interface will take the 100.20.190.2 IP address. .255.255.255.248. No shut. Interface FA0/1 IP address. This one will be 10.10.10.1, 255.255.255.0. No shut. Now the other thing is we have to apply the routing protocol as well here. Router RIP version 2. Network is 10.10.10.0. Network 100.20.190.0, and no auto summary. Let's save our config. Okay, so basically, since we have already applied the routing protocol, I should see some routes. Show IP route, and you can see from R2 I can reach the 192.168.1 network from R2. That means from here I should be able to ping 192.168.1.1, which is the IP address of the internal routers here. So there is some convergence already happening between the two routers. Let's proceed with the switch configurations of the network. Okay, so the switch is up, and I'm just gonna give it a host name. Okay, so as you can see, I'm getting a duplex mismatch on geg 0/0. The reason is the interface that geg 0/0 is connected to is basically 100 megabits per second and not 1 gig 1 gig speed. So there is a mismatch there. So let's first fix that. Interface GI 0/0. So that should take care of those mismatch duplex messages that we were getting here. Now I will configure this switch to be a layer 2 switch just for simplicity, and the connectivity will be much faster that way and easier, because it's just an internal switch. So you can configure it as layer 3, but we don't want to do layer 3 because already we have a router. So let's do that. Interface range. Let's give it a VLAN. We'll give it a VLAN, name it CCS, and I will put all those interfaces into this VLAN. Let me do range easier. We said they belong to VLAN 192. Let's also apply spanning tree port fast. I think one more thing I like to always give to a layer 2 switch is an IP default gateway. And I will always say 192.168.1.1 in this segment. 192.168.1.1 is acting as the default gateway for all the workstations. I think that's it in here. Let's save the configuration. And what I will do is I will bring up the switch, the ISP switch as well, and we will configure exactly the same scenario, the same configurations, except the VLAN will be different. Okay, so the ISP switch is up right now, and we will configure the host name first. And let's do that. Let me make it caps. Now the other thing is we need to fix the duplex mismatch message that we are receiving here, and we need to fix that. Interface geg 0/0 and no negotiation auto. Duplex. So no negotiation auto is the command that basically what it does, it by default many of these switch interfaces are usually pre-configured by default with a negotiation auto configuration, and that has to be disabled in order to change the duplex settings. And so the other thing we need to do is we need to put all these ports in a different VLAN, and I will choose VLAN 10 since the VLAN here is VLAN 10.10.10.10. It makes I think it makes sense, VLAN 10, and I'll name it ISP. Interface range I'm sure you are already familiar with the configuration of a port and assigning a VLAN. So this could be just a revision for, in most part, it's just a revision for anyone who's going to configure a switch. The only good thing that I should do now is do the IP default gateway. Ten dot 10.10.1 will act as the default gateway for the remote user as well. Let's save that. I will bring up the terminal for the remote user as well as for the internal terminal and configure the IP address as well as the default gateway on them. And then we will test the connectivity across. Okay, so I have the remote user terminal here, and I'll assign it an IP address. And the syntax is IP, and then the IP address that I will assign is 10.10.10.10, and the subnet mask is 24, and the default gateway is 10.10.10.1. And it's checking for duplicate addresses on the network. There's none, so it has assigned that IP to the remote user computer or terminal. Now I'll bring the internal terminal console, and we will do the same exact thing. Okay, so this is the terminal one, that the inside terminal right behind the CCS switch, and I'll give it the IP address as we discussed, 192.168.1.10 with /24, and the gateway address will be 192.168.1.1. It's checking for a duplicate address on the network, and it didn't find anything, and it did give it the IP address as we see here. Now, in order task 2, so we completed task 1, assigning the IP addressing to all the interfaces. Task 2 is to apply the routing protocol. We did apply the routing protocol, and we just want to make sure that the convergence is achieved across the entire network. And if I do ping, for example, from here, I'm trying to do a ping from here all the way across here. I should be able to get some response. Let's see. 10.10.10.10 I believe is the IP address we assigned the remote computer there. And let's see if we are getting any ping replies. And yes, we do get successful ping. That means the network is fully converged. Now, our task has not been finished yet, so the final task is really have this remote user ping our internal terminal using one of the public IP addresses. Now, the reason why we will be doing that is because, let's say if you are in the manufacturing facility and you have your own IP scope internally, you don't want some remote person or remote outside external user knowing your internal IP range, and that may expose your facility to the outside world, and you don't want to do that. So for doing a static NAT, this is supposed to be our task number 4 actually, and I didn't put it here, but that's the purpose of the lab. I apologize, and what I will do is, let's first come back to the topology. As you can see, always you have to look at the router that's providing you an internet access, right? So this router is in your organization, is in the internal organization's network, and this is the router that will behave as that will do the NAT translation. This interface FA0/1 or F0/1 is your inside interface, and this one, which is F0/0, is your outside interface. So let me bring up R1 again, and let's configure the inside and the outside interfaces. So I have R1 here, and we will proceed with the NAT configuration. Please follow along. Conft interface IPNet inside is the command that I will apply. It does take, it depends on your router. Usually it does take a little bit of time because the router has to compute the interface to be an inside interface for NATing, and I think it may have already done it by now, so it's done, as I can see here. And the other one that I will give is the let's go to the interface F0/0, and I'll say IPNet outside. It seems that the router didn't take any time. The reason is actually I improved the memory on the router to be more than 128 meg, and I can see a better performance from this router right now. The last thing is to map this IP address that the terminal has received to the public IP address that we have. So as you know, the ISP or an internet provider will give you a block of IP addresses. As I informed you, that it will all depend how much you pay or how much that company pays, and in this case the organization, internal organization, has received a block of 6 IP addresses, right? So that should be clear, and we will use the next available IP, public IP address that we have, and it should be .3 as I see here. So let's start by putting the configuration for static NAT. It's IPNet inside source static 192.168.1.10. That's the IP address given to the terminal, and my public IP that I will provide is going to be 100.220.190.3. Let me save this configuration. Okay, so I'll just keep this here for now, and I just want to keep it here for now. And what we will do is we will bring the remote computer terminal, and I will ping 100.20.190.3. One thing for sure, I mean, I should be able to ping this IP. The remote user should be able to ping this IP because it's already been assigned when we did the NAT configuration. Perfect. So we are able to ping this IP address. This means that it is present, it's live, and it is reaching. All right. So, but from R1, I should be able to see the translation. IPNAT, show IPNAT translation. That means what happens here by R1 is that it's receiving the request from 10.10.10.10 and it's translating it to, it's translating it to 100.20.190.3. Okay, so that's how this computer is getting a reply from 100.20.190.3 because R1 is actually translating the traffic IP addressing of when it does the translation, right? So this is basically what you see is inside global address. The inside global address is 100.20.190.3. Inside local address, that's the IP address given internally to a device. The outside local is the outside local IP address, which is from an outside organization, and outside global is an outside global IP address that's given by the ISP to that outside remote user computer. So with this we conclude this chapter or this lesson. I hope you have enjoyed the lab, and I hope I was very clear in demonstrating this lab. Thank you very much, and join me in my next lab, which is the NAT overload. Thank you very much.